Good morning, dear students. I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to teach textbook question and answers from the chapter of motion. Already in the previous videos, I clearly explained with the suitable examples of each and every topic from the motion chapter. And mainly in the previous video, I clearly explained, think and discuss from the textbook. Now in this part video especially we discuss the textbook question and answers mainly. Okay. So what are the questions already we are covered in our videos, that is I will skip, and remaining only we are discussed in this part video. So let me come to that point. Okay. First one. C moves at a constant speed in a constant direction. Listen very carefully. So they are given one statement. What is that one means? C moves at a constant speed in a constant direction. In a constant direction. Listen very carefully. Okay. It is a statement they are given. Rephrase the same sentence in a fewer words using the concept related motion. Means this sentence we can write in a fewer words. Means by reducing this one we can write in a simple sentence. Okay. Generally it is you are observing that in this statement C moves at a constant speed in a constant direction. Here mainly you are observing that constant speed, constant direction. Constant is nothing but speed does not change. Means body moves with simply uniform speed. Next one. Constant direction means body direction does not change. It will be going only one direction. That's why. So if you are observing this one, these two are related to one concept, that is uniform velocity. Once we are remembering definition of uniform velocity or statement of uniform velocity, what is that one? You know that if a body covers equal distances in equal intervals of time in a specified direction. Okay, when a body covers equal distance in equal intervals of time, if a body is moving with constant speed, when a body moves with constant speed, at that time it covers equal distance in equal intervals of time. At the same time, in a specified direction. So that's why simply, so what you can write this one? She moves with constant velocity. Simply you can write that. She moves with constant velocity. So means this length of the statement, simply we can write like this one or not. Means it is a longer words, it is a fewer words. It is a lengthy words, it is a fewer words. That's why the lengthy words we can write into a fewer words. So by this type of way. Means what are the statement they are given? First you are understanding. In the statement, constant speed, constant direction is there. Constant speed means you remember the uniform speed. Okay. But along with the speed, what they are given? Direction. That's why it must be a velocity concept. But in which kinds of velocity? Uniform. Because of, if you are clearly listen the video of uniform velocity concept, I said if a body covers equal distance in equal intervals of time in a particular or in a specified direction, that is called uniform velocity. That's why direction is in specified or constant and speed is also constant. That's why simply we can write she moves with constant velocity. second one. She moves, in the given figure below, the distance versus time graph showing a motion of two cars A and B. Which car is moves faster than the other? So listen, they are given, it is x-axis, it is the y-axis. They are given a graph. On the y-axis, they are given the time values in the seconds and the distance values in meters. It is the 0. We are considering. So the graph is the graph is belongs to distance versus time graph. In this one, they are given two vehicles like this one. It is represented A, it is represented B. That is they are given here. Okay. So by using this graph, distance versus time graph. So A car speed given, B car speed given, which is moving fast. Are understanding or not? So from this graph, how we can say among the A and B car, which one will move faster than the other? So that's why first in this one, okay, directly we can say that so A is moves faster than the B. Okay, if your idea is there clearly about uniform speed concept, okay, under the uniform speed concept, I will explain with help of the graph, distance versus time graph. Anyway, now for understanding of it, I will be proof. You can select some any one time we are considered. For example, 1 time, 2, 3, 4 seconds. Like the same way in the distance also, 10 meters, 20 meters, 30 meters, 40 meters, like we are considering. So here on the time we have taken the 4 values, on the distance we can take, on the y-axis also we can take 4 values. Among the 4 you can choose any one. Okay, for example 2 we are considering, means at the 2 seconds. Okay, so at 1 second it is 20, 2, 20, 3, 30, like anyone, or 2 seconds you are considering. For the 2 seconds, we draw a graph. Or whatever that may be, distance. For the 2 seconds time we are considering. Means if we draw an imaginary perpendicular line onto the x-axis, at the 2 seconds. This line is parallel to the y-axis. That's why this line is represented the magnitude of the body in distance values. Okay. Now from this point we draw one horizontal line for here also, like this one. This horizontal line is represented the time values. Are understanding or not? Okay. So means here we are observing that at the 2 seconds. Okay. We are observing that here, it is the D1, means this is for this point, we are observing that only first of all. We are observing this position. This is on which one? Car B position. That's why it is distance of the B car and time of the B car. We are considering that. Next, from this point, it is distance of the A car covered in the, in which time? 2 seconds. That's why time we are taking the constant. Now we can select one time. For that time we can draw the distance versus time graph by draw a vertical and a horizontal line. So now you are observing that speed is equals to distance by time. So for the A car, first we are consider S of A, speed of A car. For speed of A car means you are observing that here. What is the distance at the for this consideration point? So for example, it is 20 we are considering. 20 upon what is the time? 2. That's why S of A is equals to 10 meters per second. Next, S of B means the speed of the B car from this one. What is the distance? Maybe here we can say the 10. Just understand. 10 upon what is the time? 2. 5 meter per second. That's why from this graph we can say that So simple this one, not exact. By slope of the graph I will explain also. The speed of the A car is 10 meters, the speed of the B car is 5 meters. That's why which is move faster? Obviously car A. But okay, actually from the slope of the graph we can find the so means from the slope of the distance versus time graph we can find which one? Speed. Distance in meters, time in seconds. 0, 1, 2, 3, 4. Next here 10, 20, 30, 40. Okay. So now here we are observing that one car is the B car. Okay. It is the A car. Graph they are given that. Okay. Now we are observing that for the B car, like this. 5 we can set that 10, 15, just for understanding 20 like this. Means what is the meaning of that one? In 1 second the car will be covered 5 meters. In 2 seconds 10, 3, 15, 4, 20. Now here how many points we can set that totally? 4 points. Among the 4 you can choose the any 2 points for draw the slope of the graph. That's why I will be considering this point and this one origin. Like this. Okay. So this is the slope of the graph. Slope of the graph is equals to what is that one? Distance between the or difference between the difference in y-axis minus difference in x-axis. That is one. Then slope of the graph. Slope of the graph. So here you are observing that. You are considered this is this graph. It is right angle triangle is there. Now this line means the line which is perpendicular to the x-axis. It is for which one? It is represented the y-axis. Okay, this is represented which one? X-axis. Anyone? Let me come to that one. So we consider from here to here. This one. So this is the slope of the graph. It is we are considered y2. It is the y1 because of starting here 0 onwards to car 0, 10, 20, 30. That's why it is y1 means it is y2. Next this point x1, x2. We are considered that. So that's why this one for the vertical line starting is means which is near to the x-axis, that is the y1, next one y2. Next here x1 starting, x2 is there. So difference in y-axis. Y-axis means difference y2 minus y1 because of final minus initial upon next x2 minus x1. This is the formula. Okay, so this is the slope of the graph. So slope of the graph is equals to y2 minus y1 upon x2 minus x1. What is the y2 value? Y2 means 10. For this one is that. Next y1 0 upon x2 2 upon 0. That's why 10 upon 2 that is equals to 5 meter per second. So what is the speed of the car from the distance versus time graph of the slope? We can find from the slope of the graph of the distance versus time graph by taking the any two values. I will prove that. So 5 meters per second. Next for the A car also. For the same A car. Okay. So 1 second. 2, 3, 4 like this. For the same time, we can say that for understanding of it. Now, 2. Okay. We are against this graph. This is the slope of the graph, right angle triangle. It is the y2, it is the y1, x1, x2. That's why slope of the graph for the A is equals to y2 minus y1 upon x2 minus x1. y2 means 20, y1 means 0. 20 minus 0 upon x2, 2 minus 0. 20 upon 2, that is equals to 10 meter per second. That's why the speed of the car from the slope of the distance versus time graph, we can find 5 meter per second. But from the same slope of the graph from the distance versus time, okay, so the speed of the car A is 10. So speed of the car A is 10 meters per second. Speed of the car B is 5 meter per second. That's why we can say that car A has more speed or faster than the car B. Next, question number 3. Derive the equation for uniform accelerated motion for the displacement of a body. S of n is equals to u plus a of n minus 1 by 2. Okay, already under the kinematic equations or equations of accelerated motion of a body, the fourth one is, we know that S of n is equals to u plus a of n minus 1 by 2. Okay, so I will prove clearly that one. The same proof we can write here. Are understanding or not? Okay, so for the third question, derive the equation means you can prove this equation means really S of n equals u plus a of n minus 1 by 2. For the so under the fourth kinematic equation, I will prove this one. How we can prove? S of n minus 1 value we can take it and prove. So that's why the same answer we can write for this one also. Next one, distinguish between speed and velocity. Question number 4. Okay, speed. Next here, what is that one? Velocity. What is the differences or distinguish between speed and velocity? First one, we can write the definition on the both sides. The first point, the rate of change of motion is called speed, or the distance covered by a body in a unit time is called speed. Next, for this one, the rate of motion of a body in a specified direction is called velocity. The rate of change of motion of a body in a specified direction is called velocity, or the rate of change of displacement is called velocity. You can write the definition first one. Second point, speed is a scalar. Next here, velocity is a vector. Third one, speed cannot be negative. Velocity may be negative or positive. That is depend on direction. Listen, speed cannot be negative. Velocity may be negative or positive. That is depend on the displacement or direction of a body. Next, fourth one. Okay, speed is always, the magnitude of the speed is always positive. The magnitude of the velocity is maybe positive or negative. Okay. So next one, it cannot be zero. It can be zero when displacement is zero. It cannot be zero. It can be zero. So listen very carefully. First, you can write definition. Second one, scalar. It is the vector. It cannot be negative. It can be negative or positive based on the direction. Speed is Okay, always positive. It is maybe positive or negative. Speed cannot be 0, but velocity can be 0. That is one. When the velocity is 0, if displacement is 0, velocity is also 0. Already we discussed very clearly. Next one. What do you mean by constant acceleration? Constant acceleration means under the acceleration concept, I clearly explained this one also. Okay, once you can see that video. But now just I will tell you, constant acceleration is nothing but uniform acceleration. That's why how we can write for this one means when a body or if a body changes in velocity is equal in equal intervals of time. Listen very carefully. Okay, the change in velocity of a body is equal in equal intervals of time. Then we say that the body is moved with uniform acceleration or constant acceleration. 1 second, listen. Okay, the change in velocity of a body is equal means change in the velocity is equal between the two time intervals. The change in velocity is equal in equal intervals of time. Then we say that the body is in uniform acceleration or constant acceleration. For example, it is the P point, it is the point A. We are against this one. Okay, a body of mass is m starting from point A. Okay, its initial velocity is 0 meters per second. Where during its motion at point C, the body is moved with V of C is equals to, it is V of A is equals to 0. It is at point C, it is in the motion, just for understanding, 10 meters per second. At V of D, 20 meters per second. At V of B, okay, 30 meters per second, and it is moving continuously. Okay, 1 second, 2 seconds. For here, 1 second, 2 seconds, 3 seconds. Time. Speed. We are considered that here, or velocity. Sorry. So, first one, these 2 points we consider that. Acceleration of AC means between A to C. That is because of for the entire journey, first we consider the 2 points A and C. Okay, what is the formula? V minus U by T. Okay, U is the initial, V is the final among our consideration point. Among these 2 points, this is the initial, it is the final. That's why V of C minus V of A by T. Okay, so T is nothing but here, T equals to 0. It is 1 second, 2 seconds. In this one also you can write, okay, T2 minus T1. VC value, what is that for 10? 10 minus 0 upon T2 means 1 second, 1 minus 0, that is equals to 10 by 1, that is equals to 10 meter per second square. Next you have consider these 2 points. V of D 20, V of C 10. That's why 20 minus 10, 10. 2 minus 1, 1. That's why 10 upon 1 means 10 by 1 is nothing but 10 meters per second. Okay. What is the difference? 1 second. What is the difference? 10 meter per second square. That's why here we are observing that the change in velocity here 10, 10, 10. That's why the change in velocity is equal in equal intervals of time. 1 second. 1 second. Sorry. So the change in velocity here 10, here 10, here 10. Time 1 second, 1 second. That's why the change in velocity is equal in equal intervals of time. Then we can say that the body moves with constant or uniform acceleration. Next one. A train of length is 13 meters. A train of length 15 meters is moving with a constant speed of 10 meters per second. Calculate the time taken by the train to cross an electric pole and a bridge of length 250 meters. Okay, so here they are given a train length is 15 meters. It is moving with a constant speed 10 meters per second. So it is a track is there. Here one train is there, or locomotive, or a train. This is the engine. It is the last compartment or wagon. Okay. What is the length of the train? L is equals to 15 meter. The length of the train is 15 meters from engine to end of the compartment or wagon. Okay, here one bridge is there. This is the bridge. Okay, what is the length of this bridge? 250 meters. Length of the bridge is equals to 250 meters. Length of the train is equals to 15 meters. They are given. Here one electric pole is there. Electric pole. Okay, so now we are considered that the electrical means when compared to length of the train. Okay, so the length or the width of the electrical pole is very less. That's why you are neglected the width or length of the electrical pole. That's why you are not considered. But this train is moving 10 meters per second. This is the speed of the train. Listen very carefully. The length of the train is 15 meters. It is moving with 10 meters per second constant speed. It will be crosses an electrical pole on the bridge of length 250 meters. How much time it will be taken to cross an electrical pole and the total length of the bridge? That is one. That's why here you can find the two. Okay. First one is time taken to cross an electrical pole. That is one. Time taken to cross an electrical pole. That's why time taken means that what is the formula? Speed is equals to distance by time. That is the formula, we know that. From this one, t is equals to, we can write distance by speed, because of it is transferred to this side. We are observing that st is equals to d, then t equals to s again transfer to this side, d by upon s. That's why we can write directly here. Okay, so t equals to d upon s means distance by speed. What is the distance? Which distance here? Okay, I will say that electrical pole, the length of the electrical pole when compared to the length of the train, you are negligible. But here, when what is the distance we are concerned means the length of the train. How means the train will be comes to here at this position. When the engine will be started to cross the electrical pole, that is not to complete the crosses the train entire the electrical pole, because of when this one will be comes to here, it is the last wagon, it is the engine. If this means in a train, from engine to last end of the wagon or compartment will be crosses the electrical pole, then you can say the total train is crosses the electrical pole. If only the train engine is crosses the electrical pole, that is not correct, because of here train is nothing but you can consider from starting means from engine to last compartment. That's why you are considered that here the length of the electrical pole we have not considered, because of its length or width is negligible when compared to the length of the train. That's why the train length we are considered as here. That's why 50 meter means 50 meter length of the train is crosses the electrical pole from to this one upon what is the speed? 10 meters per second. Okay, so note this one simply. So that's why 5. What is the time? Second. 5 seconds means 15 meters length of the train move with the 10 meters per second. This train is crosses an electrical pole in how much time? 5 seconds only. Next, second one. Time taken to cross a bridge. What is the length of the bridge? Here we are observing that. Okay, simple I says that. If the train is coming like this one, it is the engine, it is the last compartment. If the train will come to here, okay, it is enter onto the bridge, it will be means like this one. If the engine will crosses the bridge, do you say that the total train is crosses the bridge? No, because of still some part of the train is on the bridge. That's why if the total train like this one come to here, means here, okay, when the train will be come to here, what is the total length of the bridge? 20 meters. And what is the length of the train? 15 meters. That's why the length of the train and the length of the bridge both are considered, because of when the engine will be entered, means when engine will be started, and again the last end of the compartment will become outside, up to that one you are considered, means is nothing but because of here initially the length of the electrical pole when compared to the length of the bridge, it is very small, very small. That's why you are not considered this length. Otherwise you are considered this length and this length. Now here 15 meters length of the train to totally cross the bridge means you consider length of the bridge plus length of the train. That's why. So the time taken to cross bridge. That's why. So same formula. So means here, what is the D? 250 plus 50. That is equals to 300 meters. Means the length of the train is 50 and the length of the bridge is 250. Totally 300. Now the same formula. T is equals to D by S, means distance by speed. What is the distance? 300 meter to cover the which one? To cross the bridge, and speed is 10. 0 cancel. What is that one? 30 seconds. That's why. So the time taken to cross an electrical pole in 5 seconds with the speed of 10 meters per second of 15 meter length. The same time to crosses 250 meter length of the bridge, in how much time it will be taken? 30 seconds. The remaining questions we will discuss in the next part of the video. Okay, thank you.